We're going to go over this today. Now, are there any questions on problems 1 or 2? Questions on problems 1 or 2?
No, but can we do one just for the next bit?
So if we look at 1, we first, for any of them, we really want to look for a greatest common factor, because if we can factor out a greatest common factor, it'll make them easier to work. So if we look at this here, between 6, 36, and 71, is there a number that goes into all three? Well, no. Okay. Then we can look at the variables.
B squared.
There is a b squared in all of them, and an a. So we have an a and b squared in each term. And we can factor it out. So we'll still have the 6 because we're not factoring any numbers out. All the signs are going to stay the same. But if we factor out 1a from a cubed, we're left with a squared. And the b squared will factor out completely. Minus 36. And if we factor an a out of a, it simplifies out completely. And the same with b squared. So we're just left with minus 36. Plus 71. If we factor an a out of a squared, we're left with 1a, and the b squared factors out completely. Now, if we wanted to rewrite it, we can as 6a squared plus 71a minus 36 to have it in standard form. No, and that's actually as far as it goes, because that doesn't factor, unfortunately. And one way we can check is by taking the square root of b squared minus 4ac. Just typing that in the calculator and seeing what we get. If we get a whole number, then it does factor. If we get a decimal, a non-repeating, non-terminating decimal, it will not. Yeah, 4ac. So 71 squared minus 4 times a was 7, no, 6. And it was negative 36, wasn't it? Yeah. We get a decimal. So it doesn't work. It doesn't factor further from there. So this here, or either one of these, is our final answer. Questions on this here? Questions about number 2? Because number 2 is a difference of perfect squares, which will end up being 6x plus 7b times 6x minus 7b, because this is really following our a squared minus b squared, which ends up being a plus b times a minus b. Because what times itself is 36x squared? What? 6x and 6x. 49b squared would be 7b and 7b. They're perfect squares, so it kind of follows that pattern. Because 6x would be our a's, 7b would be our b's. We kind of plug it in. Questions on this here? Any questions on 2 or 3? And yes, there are 2 2's. Yeah. Whoever wrote this up must have been tired or just not paying attention. Yeah, no, there's errors, as y'all have seen so far, like that throughout the review sheets, and I don't feel the need to fix them because it's a review sheet. It doesn't, problem number really doesn't matter. But any questions on how to do number 2 or number 3? Do you feel comfortable with these? Okay. Questions on 4, 5, 6, or 7? Now, for the most part, and especially on the test, if we have 2 terms, it's either going to have a greatest common factor, something we're just going to pull out, difference of perfect squares, or sum or difference of perfect cubes, because that's the only way we can factor with 2 terms. Now, looking at this here, we know it's not a difference of perfect squares. 1, because it's not a difference. Now, if we look at both of them, there's not a greatest common factor other than 1, and 1 factoring it out doesn't do anything, doesn't change anything. Now we need to see if it's a sum of perfect cubes. Can we take the cubed root of both terms? What's the cubed root of a to the third? A. We're looking for something times itself 3 times, and that would be a. Now the cubed root of 1. 1. That's kind of the nice one because it doesn't matter what root we have. If we take it of 1, it's always going to be 1. Two terms being subtracted, and they're both perfect squares. We can multiply it by itself. 64 would be 8 and 8. 1 is still 1 and 1. Now, when we look at this here, so I have a little more room. Now, we can set this up. So 3 and 5. So sum or difference of perfect cubes is one where we have a parentheses with 3 and then a parentheses with 5. And we know it's a sum of perfect cubes because 1 is addition, and 2, we can take the cubed root of both terms. Now our signs are going to be the same. Opposite always end on a positive note. So plus to be the same, minus for opposite, always end on the positive note, it's going to be plus. Now our first term is A. Our second term is 1. In the general case, B would be where it goes. In this case, our B value is represented by 1, or 1 is taking the place of B, however you want to think of that. But what we're plugging in is 1. Now, in all the example problems that we did, especially for factoring note sheet 3, we did the first term all the way through and then did the second term all the way through. If you want to type it in all at once and not do one at a time, that's fine. If you want to do it one at a time, that's perfectly fine. Either way works. Do what you feel comfortable and what you understand. Now, in the bigger one, we can do the first term next. So we'd have a squared, a to the first, and then we don't necessarily put the last one because a to the 0 is 1, and we're just doing 1 times the second term. Now, for our other one is 1. We won't put it with the a squared. In the middle, it's just going to be 1 to the first, and then 1 squared. And yes, it is going to be 1, but in the last case, 1 squared, we do need that number there. It's going to end up being 1. We don't put the 0 because the other term normally takes its place. Here is kind of the funky situation where it ends up just being 1. But otherwise, it's good to write those other ones in. Questions on how we got to this point here? Now we just need to simplify. So we'd have a plus 1 times a squared minus 1 times a is a plus 1 squared is 1. So we get this here. Any questions on this so far? So what would number 6 be? Yeah, we can take square root, 64x squared. Yep. 8x minus 1 times 8x plus 1. If you had it as 8x plus 1 times 8x minus 1, that is the exact same thing. Because which one is plus and which one is minus, really doesn't matter which one comes first or second. We just need them both. Questions on this here? Finding these easier and easier to do the more that we do them. Questions on 8, 9, 10, or 11? Well, 10, that's the answer. Because we don't have a sum of perfect squares. It's not 1, so that doesn't go anywhere. Yeah. Because it has to be minus. Because the only way this would work is if it's perfect cubes. 2 terms perfect cubes. x squared prevents us from doing that. Also, 49 does not have a cubed root. 36 does not have a cubed root. We can't go anywhere with it. There's not going to be one like this on the test because there's no greatest common factor either. So literally, if this was on the ACT and told you to simplify it with real factors, it's simplified. It can't go anywhere. There won't be anything like this on the test. You will be able to do at least something to them. Be that just factoring out a greatest common factor and then being done, or two sets of parentheses. There will be something. Now, any of the others that we want to look at? 11. Greatest common factor is where I would start first, especially if it looks weird. Yes.
7x squared.
And especially if it looks like it should be a difference of perfect squares, and one of the numbers are really going to end up being both the numbers aren't perfect squares, look for greatest common factors. There might be a greatest common factor that you can pull out that will make them perfect squares or perfect cubes, then go from there. Now, if we factor the 7 out, 7 out of 49, x squared out of x to the fourth is plus 343 divided by 7. 49 x plus 1. Because any time it factors out completely, it is going to be 1. Because realistically, when we do the factoring out, we're just dividing each term by what we're factoring out. And the last one becomes 7x squared divided by 7x squared. Anything divided by itself is 1. So we have this here. Is it likely that this is going to factor? No. And one way we can see it is because when we do our multiply, our check for the middle, I'm multiplying the factors of 7 by the factors of 1, and I'm trying to somehow add that together to get 49. 49, that's not going to happen. If it had been 7 instead of 1, then we could have actually done this. But this does not factor any further. This is the final answer. 8, yes. 8. So this here is kind of what I was talking about earlier, or just a few minutes before this one, because x squared 2 terms, and it is being minus, yes? So what we are most likely looking at is a difference of perfect squares. But 8, if we take the cubed root of 8, not cubed root, looking at square root, let's try this one more time. Let's make it square root 8. We get 2 square root of 2. That's not a perfect square because we have the radical left over. We don't want radicals. And I believe the other one was 72, yes? That one's not a perfect square, but they do both have the square root of 2 when we take it, yes? So let's look back here. Is there a greatest common factor between 8 and 72? What is it? 8. Because if I factor 8 out of x, 8x squared, we're left with x squared minus 1. 2 would work. Because if I factor the 2 out, you don't have to write this down. I'm going to put it over here. We would have had 4x squared minus 36. Is 4 a perfect square? Yes, is 36 a perfect square? Yeah, but we will still end up having a greatest common factor that has to come out later. If we pull the 8 out, x squared is a perfect square, yes? 9 is a perfect square, so it still works. 8. So here it would be x and x. Perfect squares for 9 are 3 and 3 plus and minus. Questions on this here? Not too bad. Now with the other one, 2, this would be 2x plus 6 times 2x minus 6. So if we saw 2, we can factor it out. But it is good to make sure when we look at it before we're done Do we have greatest common factors in either of those parentheses? So yes, we have a 2 here. So I can move it out front. And we also have a 2 here, which gives us x plus 3, x minus 3. Yeah. We essentially get to the same thing, but we end up having to factor that out later. Any other questions on number 8? Questions on 9? Why don't we look at it? 25x squared minus 10x minus 3. Is there a greatest common factor? No. Two sets of parentheses with 3 spaces. Now we need to find our signs. Since the third term is negative, our signs are opposite. Yep, plus and minus. If the third term had been positive, the signs are the same and they match the sign of the middle term. Now, normally when we did this here, looking for the factors of the first and third term, we normally always start with first term. It's just because it appears first. So we do know we will need x and x. And the factors of 25 are 1 and 25, or 5 and 5. 5 and 5. Now, for a problem like this here, if I was going through and factoring it, I would have done the 3 first, because 25 has 2 different sets of factors. How many factors do we have for 3? 1. There's only one setup, and if there's only one setup, I just go on and throw them in. I'm not really too worried about if I have them in the correct spots at this point, because we will check it to make sure. And luckily, if I don't have them set up, we have an eraser and we can fix it. 5x times negative 3 is negative 15x. 1 times 5x is plus 5x, which gives us negative 10x. That's it. And just as a reminder, if we do get the correct number but wrong sign, flip the signs. Flip the signs, because that's going to be the easiest way to get there. Any other questions on these 4 here? Questions on 12 through 15. 15? Is there a greatest common factor? No. And the a squared kind of gives that away. The number squared, if it's by itself, most likely there's not going to be one. Unless there's a variable in all 3. All right. If the third term is negative, our signs are opposite. If the third term is positive, our signs are the same and they match the sign of the middle term. So here they're opposite. Now it's kind of nice for us here, because factors of a squared are a and a. 2 and 3. Yeah. We should put it the other way. I just want, because if we do it this way, a times negative 2 is negative 2a. 3 times a is plus 3a, which gives us a positive a, yes? Now, this one here, we can flip the 3 and 2 and get the correct answer. Or we can flip the signs. The reason that we can flip the 3 and 2 here instead of flipping the signs is because what is the values in front of a? 1 and 1, yes? So flipping the 3 and 2 is not going to be a big change because it's still being multiplied by 1a either way. Like the last one where we had 5a and 5a or 5a and 4a. Flipping the last term is not going to change just the sign. It'll change the number as well. Does that make sense? So sometimes it's easier if we get the correct number, just go on and flip the sign. Because then it's just going to change the signs. It's not going to change the numbers. But when a is 1 or the variable just has 1 in front of it, or it's the first term, that'd make a big difference either way. But it's easier to just switch signs and do it that way. Questions on that one there. Any other questions on 12, 13, or 14? 14. So we do have two terms. And we can look for a greatest common factor, but the only real factors of 8 are 1, 8, 2, and 4. 729 is not divisible by 2 because it's not an even number. Divisibility of 4 is the last two digits. So 29, if 29 is divisible by 4, then the number is as well. Well, 29 is not divisible by 4. 8 is the actual same thing as 4. It's just seeing if 29 is divisible by 8, which it's not. So there's not a greatest common factor. Now we do have a difference. So it could be the difference of perfect squares or the difference of perfect cubes. X to the third. So I'm going to guess cubes if this is going to work. So we can take the cube root of 729, x to the third. And we're going to take the cube root of 8. Well, cube root of 8 is 2. And this here will have an x. 9. 9 to the third is 729. So it is 9. So we have 9x and 2. 3 and 5. So our signs are going to be the same, opposite, always end on a positive note. So since it's difference, we'd have minus, plus, plus. Now our first term is, so we'd have 9x. Here we're going to have 9x squared, 9x to the first. We don't have to worry about 9x to the 0. Our second term is 2. So we'd have 2, 2 to the first in the middle, and the last one is 2 squared. Luckily, simplifying the first set of parentheses is nice because we don't have to do anything. We just rewrite it. Now 9x squared, 9 squared is 81. And x squared is x squared plus 18x plus 4. Questions on these here? Some of the difference of perfect cubes and the difference of perfect squares are nice because as long as for some are difference of perfect cubes, we have two terms, they're both perfect cubes, it works. No matter what they are, it works. And the same thing for difference of perfect squares. Questions up to 15. We ready for the next set of 4? Well, might be next set of 3. Yeah. 16 through 18. 16, 17, or 18. Any one of those three that y'all want to look at. Questions on 19 through 26. Let's just look at the whole page. Anyone on that page that y'all want to look at? 26. Now, this is going to be our factoring by grouping. When we have 4 terms, it's going to be factoring by grouping. I was going to say more, but really the only grouping we've done are groups of 4. If we want to, because I believe y'all are wanting to look at this because the numbers are significantly big, yes? Now, we haven't done this up to this point, but is there a greatest common factor between all 4 terms? 5. So there's absolutely nothing wrong with pulling a 5 out from the very beginning, pulling it out from everything. Because if we do that, 5 out of 105 is 21 into the third. Plus 75 divided by 5 is, I think it's 32, isn't it? 15, no, 35. Minus 5 out of 75 is 15 in, minus 25. 15, 25, 5, 125, 5. Yep. Do these numbers look nicer than they did before? Yeah. And if we wanted to factor it completely, we're going to have to pull that out anyways. So greatest common factor is a great place to start. Now at this point here, we can group them 2 and 2. So we can look at the first two terms. What number and variable will go into both? N squared. What about 21 and 35? 2 won't go into both. 7. 7 times what is 21? 3. And if I take n squared out of n cubed, we're left with n plus 35 divided by 7. And the n squared factors out completely, yes? So that works. And I kind of gave us a hint at what the other set of parentheses is going to be inside of it, yes? Because if we're going to do this again, what's inside here has to be 3n plus 5, yes? So we can factor out a 5, yes? What would the sign be? Because the 15n and 25 are both negative. We need them to both be, so we have to factor the negative out. So we have this here, yes? 5, parentheses. Because what can we factor out of both? And if we factor it out of our first one, we're left with, and then minus 5. And that's it. Questions on this here? It is a little funky, and yes, I did drop a set of parentheses, but we didn't need the extra set. The parentheses in front of the 7n squared. Because when we factored it out, we pulled it out front. We could have put a set of parentheses around it. It wouldn't have made a difference. So I can included those there. It wouldn't have changed the answer. It just means the whole thing's being multiplied by 5 once. There's only one of them. It's not multiplying 5 by both of them. Any other questions up to 26? We feel good with these here. Questions on 27 or 28? 27. So again, what do we look for first? Greatest common factor. So what goes into both of these here? Squared. And if we factor 12x squared out of 12x cubed, we're left with x minus. That's it. Any questions on any of this here? Yeah. 15x, which would give us x plus 2. So your test is tomorrow, and I'm going to give you till next Wednesday to get the homework turned in. I don't